Hello everybody, good afternoon, welcome to my live. Welcome everyone, welcome. Happy Thursday afternoon if you're in South Africa. If you're not in South Africa, I don't know. I'm Miss Martins if you don't know me. So as I start, yes, Burger King and Eta, you were first. Good afternoon. Awesome. So, listen everyone. If you've been in a live before, welcome back. If this is your first live, welcome. You're now my student. I'm Miss Martins. While we wait for people to join, please comment down below what grade you're in. I love to know what grade everyone's in. I love to know, what you're doing in physical sciences at the moment. If you are in grade 11 or 12, please share this video with your friends because it will benefit them. Grade 11 and 12, physical sciences students especially. Obviously, if you're not in grade 11 or grade 12 and you're just here to see what it's about, pop in, say hello, see what kind of work we do in grade 11 and 12 physical sciences. You're more than welcome to stay. And obviously, if you're in university, that's even cooler. Maybe you miss high school physical sciences. We're busy with organic chemistry. Okay, cool. So if you're in grade 11 or 12 or grade 10 actually, comment your grade and in the same message, comment what you're currently busy with in physical sciences. It helps me to know what my followers are currently doing so that I know what to base my, my lives around in future. So I know that, for example, in my school, my grade 11s are busy with Newton's laws. My grade 12s are busy with organic chemistry. I know that some schools switch the topics around. So it might be that your school is doing it later, or you've already done it, or you've swapped it around. We've just started Newton's laws, Newton's second law, Newton's laws. Okay, cool. So the timing of this live is good. Now, the matrics that are in here, you might be thinking, why did ma'am label this grade 12 live? Well, I'm sure you guys know. You did Newton's laws in grade 11. Now, I explained it to my grade 11s and 12s today. They know this already though. I said grade 11 is when we generally do Newton's laws. It's a grade 11 topic and it's examined in grade 11, but it's actually a matric topic as well. Grade 11 vectors. Okay, so you'll move on to Newton's laws soon. Okay, so it is a grade 11 topic. You do it in grade 11, but you are examined on it in grade 12 again. It is a big question in your final paper 1, your physics paper 1 in grade 12. So that's why I've said the grade 12s need to join. Even though you might not be examined on it in this term, you will be examined on it either probably in your definitely in your prelims. Okay, so we're going to get started because obviously there's quite a lot to get through. I'm just letting everyone know that I'm going to be going over a little bit of theory relating to forces and Newton's laws. Then we're going to cover Newton's first and second law, a few examples that I took from past papers. So this may be something that you haven't done yet. Then you're going to find this tough. If you haven't done Newton's laws yet, you might find some of the examples a bit difficult because, I'm not easing you in with easy examples. But if you've already done this and you're ahead and you've done a lot of examples of Newton's laws, you might find these easy. So I'm trying to cater for everyone. So if you are bored, that's great. Just take it as revision. All right, guys. I will try and save the live and post it later. It's just often TikTok has issues when it comes to saving my lives. I'm not 100% sure why it doesn't work sometimes. So if it does save, which I cannot guarantee, I will save it and I'll post it on my YouTube channel. So just for everyone, before we get going, I do have a YouTube channel. There aren't many videos on there at the moment, but I am uploading as the term goes on. It's Maths and Science with Miss M. That's my YouTube channel. There's a few videos there on grade 11 and grade 12 physical sciences already, so you can go check that out. And if you don't follow me already, please don't forget to follow me because I'll be doing loads more videos and lives in the future. I also do study tips and study hacks and stuff. You're a teacher. Awesome, welcome. Okay, so here's the part where you share the video with your friends. I can see you got your comments as we go along, so I'll try my best to read them while I'm doing the work. Okay, if you've just joined, welcome. I'm Miss Martins. We're doing Newton's laws. It's aimed at grade 11s and 12s, but obviously if you are not in grade 11 and 12, then you are welcome to stay. You share by clicking the little arrow at the bottom of the video. Awesome. So share the live video with your friends, and new people that are joining, welcome. Welcome. Follow me for future ones like this. Let's get into this, guys. Now, remember, like I told you, so I'm just going to switch my camera so I can still see you. I hope you can still hear me. I'm going to switch the view of my camera so that you can see my notes. Remember, I told you, some of you might find this easy. Some of you might find this tricky. It all depends on where you are in your journey with learning about Newton's laws. So, my first page over here, I say Newton's laws, and I say in order to understand Newton's laws, you need to understand vectors and resolving vectors into their components, and you need to know forces. These topics are all linked together. So some of you I know are still here and you haven't moved on to Newton's laws yet. That's fine. Hopefully this will give you a little bit of a head start. Right, so let's get going. If you have any questions, if I'm going too fast, just let me know. I will try and cater for everyone. We're still doing vectors. Comment below if you're still doing vectors. And if you're doing Newton's laws, tell me how far you are with Newton's laws, everybody. And do you feel like you've done enough practice? Okay, so this is a little summary page, very quick summary on vectors. We know that vectors are physical quantities where we need magnitude and direction. Now, magnitude sounds like a big, scary word, but magnitude means amount. So if you read a question, so I have questions coming up later. Let me show you. And it says, for example, let me show you. It makes so much sense if I show you. Do you see in this question? I hope you can see. I will zoom in later. But it says calculate the magnitude. Calculate the magnitude. So magnitude is basically like the size or the amount. So for example, the magnitude of velocity would be like 3, and then the unit is meters per second. Direction must be given if they just ask for a vector in general. If they say calculate the magnitude, then you don't have to give direction. These are the different types of vectors that we have done. So I'm assuming all of you are aware and know about all these vectors. If you see a word on this page that you don't know, then let me know and I will quickly explain it. Do you recognize all of these vectors? So we've got displacement, we've got velocity, acceleration, force, and these are the different types of forces that we are going to be talking about. I don't know how to apply Newton's second law. Okay, so hopefully that'll help this lesson. So does anyone not know any of these vectors? I'm assuming that you guys are fine. What I want to point out to you guys, and I've shown this in a previous live. So if you missed that live, you would want to know about this. You need to get hold of this document. It's the exam guidelines. It was made last year, but remember, this will apply for this year as well because they amended it because of COVID. So these are the exam guidelines. And in this little document, it tells you everything that you need to know for every single section for grade 12. And if you look at the exam guidelines, there's a section on Newton's laws. So you can look through the document at your own time. I'm not going to go through it now because it's going to take up time. It's grade 11 and grade 12. If you look through the document, here it says everything that you need to know about Newton's laws. It tells you what you need to know. It tells you what definitions you need to know. It tells you what type of free body diagrams you need to know. It tells you what sort of questions you need to be able to apply. So this document is an absolute lifesaver when it comes to matric and in grade 11 as well. So if you're in grade 11 and you need to know, do I know everything about Newton's laws? You take a look at this document and you go through it almost like a checklist. Hello, everyone that's joining. I'm Miss Martins. If you don't follow me, please do so I can help you in the future with science. Awesome. So you need to take a look at that document. In that document, you get your formula sheet. Let me try and drop you down so you can see this formula sheet a bit clearer. So here I've got a formula sheet. Now, when we do Newton's laws, we're going to be using F net equals ma. We're going to be using these formulae. I hope you guys recognize those. Does anyone know what you use that formula for? What do we use that formula for? What do we use that formula for? And then this is W equals mg. All the ones that I've highlighted, those are the formulae that you're going to be using in the Newton's law section. So we've got formulae about motion, yes, static friction, kinetic friction, yes, we're going to be going over that. So you cannot forget about equations of motion from grade 10, guys. You absolutely cannot forget about equations of motion. You will use them in these questions. Then what I've done over here, and I did this for my learners, is I've printed out a definition list of all the definitions you need to know for this section, okay? And these are definitions that can be examined in grade 12. So we've got normal force, frictional force, static friction, kinetic friction, Newton's first, second, third law, law of universal gravitation, and weight. This is important. These ones are the definitions you need to know. And like I tell my students, and you guys are now my students, so I'm going to tell you the same thing. You need to know these definitions off by heart. So I would recommend create flashcards for them, print this list out, see if you can memorize them, say them to yourself. You need to know these off by heart. Thank you for the rose. You need to know these off by heart. So I can link these definitions for you guys in my bio. So please, if you want to access the link in my bio, I do think you need to follow me. I don't think you can access it without following someone. I'm not sure. So it is in the link in my bio. I will put it there. Now, let's go on to some forces. And the reason why I'm doing this is because if you guys don't know these, you cannot move on to Newton's laws. You absolutely cannot move on if you don't know these. So the first thing that you need to know, and I'm going to go over this quite quickly. So if I'm leaving you behind, please tell me, but I'm going to make an assumption that most of you know this and it's relatively easy. So a normal force, that's the definition. Basically, it's the force that the surface exerts on an object. So here you can see I have a box on a table. Here I have a box on an inclined plane. The normal force is the force exerted by the table upwards onto the object. And the thing about the normal force is it is always perpendicular, 90 degrees to the surface. Okay? Over here, now this is where a lot of learners make a mistake. They see the surface like this and they see the object and they think normal force goes like this. They think it always points straight up. No, it doesn't always point straight up. In this case, it points straight up because that's at 90 degrees to that surface. Here, it needs to be, here's my surface. My normal force is at 90 degrees to my surface. So I'm going to go like this. This is my normal force. Do you see? It's at 90 degrees to my surface. Almost imagine that you're going to measure it with a protractor, right? See, more or less get it 90 degrees. Now, that is my normal force. So it is really just the force that the surface exerts on the object that it is in contact with, and it's at 90 degrees. And that is the symbol, Fn or N. And because it's a force, it's measured in Newton. Let's go on. Applied force. Guys, an applied force is any force that I exert on an object. It can be a push force, it can be a pull force, but it's due to contact. So if I pull this with a rope, if I push this box, those are all applied forces. Here the applied force is horizontal to the surface, not at an angle. Here the force is at an angle relative to the surface. Okay. Now, does anyone know what we need to keep in mind when I have a force that is acting at an angle relative to the surface? What do I have to keep in mind? So here, my applied force of 20 newtons is acting at an angle of 30 degrees relative to the surface. What I need to remember is this is F applied, but when I do calculations, I need to know how to break this up into its components. Do you guys know what I'm talking about? Let me know if you know what I'm talking about so that I know if you're with me, if you've done this, if this is boring, if this is easy, if this is difficult. So F applied is going at an angle. I can break that force up into this force going to the right. So check it, F applied. It's going up and to the right. Up and to the right. This force is going to the right. This part of this component is going up. Now, grade 11s and grade 12s, I want you guys to think about it. Up and to the right is the same as going to the right and up. These two red arrows together give me that blue arrow. This one we can call F applied parallel or F applied horizontal, or F applied in the X direction. This one over here is called F applied vertical or F applied perpendicular. Do you see it's perpendicular to the surface? If applied perpendicular, it's perpendicular to the surface. If applied parallel, it's parallel to the surface. Vertical, horizontal. Y, X. How do I work out the value of F applied parallel? We use trig. Yes, Fy and Fx, exactly. This one would be Fx. This one would be Fy. It's just got different names, and it depends on textbooks, it depends on your teacher, it depends on a lot of things. So how would I work out F applied? Let's go with F applied perpendicular first. So F applied perpendicular. Yes, sorry, to those asking, it is grade 11 and 12 physics. Yeah. So how would I work out F applied perpendicular? So if you look at this is a 90-degree triangle. This is where my 90-degree angle is. That means this is the hypotenuse. If I want to find F applied in the y direction, or Fy, or F applied perpendicular, I'm going to use sine. Yes, you use sine. Well done. And why do you use sine? Because here's the angle, and I'm looking for the one opposite the angle. So we go 20 sine 30. That is how we get F in the y direction. Force applied in the y direction. Well done. So force applied in the y direction is this one. You see it's along the y. It's opposite the 30, so we use sine. Okay. If I want to get F applied parallel, or F of x, look at where the angle is. It's adjacent to the angle. So I go 20. 20 is my applied force. Because it's adjacent, 30, because my angle is 30. Then of course, we can work this out and get a value, and our unit will be Newton. Why? Because force applied is a force. It's a force, it's measured in Newton. So you can get an answer for this. And remember, if you do, and that's the end of the question, you round it off to 2 decimal places. Thank you so much for the rose. Okay, anyone have any questions about this? If you have not done this yet, this is going to look crazy difficult. You're going to be confused. If this confuses you, you can think of, I'm looking for sine theta. Sine is opposite. Opposite is Fy. Opposite is Fy. Over hypotenuse is F applied. Okay, my F applied is 20. So it's Fy over 20 is equal to sine 30. You take the 20 over. That's why it's 20 multiplied by sine 30. So what's the question that we apply this working? So basically what we would be doing when we use this is they would ask you for the horizontal and vertical components of F applied. We generally do this within a question. It's not really a question on its own. Okay. Remember, if I've already lost you and I'm going too fast, then and you haven't started this work yet, I don't want you to stress out. Because the point of this live is I'm trying to get to some past paper questions. Here is weight or force of gravity, and that's the definition. And we know to calculate the force of gravity, another symbol for Fg is W, little w. Fg, or W, is equal to the mass of the object in kilograms times gravitational acceleration. That gets me the weight. And the weight of the object always acts straight down like that. It's always from the center of the object. It's pulling the object to its surface. Okay? Is normal exactly equal to the gravity? I love that question. Thank you so much for asking. So basically, that's what I wrote over here. If the object is on a flat or horizontal surface, the magnitude of the weight is equal to the magnitude of the normal force. But, and this is a big but, guys, that is only true if there's no other forces acting upwards at all. So we're going to do an example where I'll show you, where we have a box like this. So if I have a box and I have a table and I have the force of gravity is going down like that, and the normal force is going up like that. If there's no other forces acting on this box, then the normal force is equal to the force of gravity. Okay? The magnitude. The magnitude of the normal force is equal to the force of gravity. So if I tell you that this box has a mass of 10 kilograms, how can you calculate the normal force? Well, we go the force of gravity is equal to mass times gravitational acceleration. Mass is 10, gravitational acceleration is 9.8. So the force of gravity is 98 newtons down. So the magnitude of Fg is 98 newtons. Now, because there's no other forces acting in any other direction upwards like this, that means that the magnitude of the normal force is also 98 newtons. These essentially balance or cancel each other out. Thank you. These balance or cancel each other out, and our net force in this direction is 0. And that should make sense to you guys. If I have a box sitting on a table, like let's say this eraser, that is sitting on my tabletop over here. So here's my table, okay? Here's my table. It's sitting on my table. Is this box or this object or this eraser moving in this vertical direction? No, it's not. This box is sitting on my table. It's not moving in this direction. That means the net force in this direction is 0. And that's because these two forces cancel each other out. All right, let's carry on. So that is exactly what I'm saying over here. However, if I have a box on a table, now this might confuse some of you, so just focus. I have a box on a table, and I'm applying a force like this. That is my force applied. That is my force applied. Now, what forces are acting on this box? Okay, what forces are acting on this box? Well, we've got the force of gravity going straight down. We've got the normal force acting up like that. And we've got force applied. So if I had to draw a free body diagram of this, that's not a free body diagram, by the way. This is a free body diagram where I represent the object by a dot. And I go, okay, cool. The force of gravity is going straight down. You guys, please use a ruler. I should be being a bad teacher here. There we go. Fn is going up. And then F applied is going like this. Force applied. Now, you guys tell me, in this situation, does the magnitude of the normal force equal the magnitude of the force of gravity? Are these two equal in this situation? No. So they were equal in this situation, in magnitude, equal in magnitude, because there were no other forces acting up in the vertical direction or down in the vertical direction. In this situation, this Fn is not equal to Fg. Yes, there's another force. I love that. Now remember, force applied I can break up into components. I'm going to call it Fx and Fy. Now basically what we're going to be doing later is, first of all, does everyone understand that I'm breaking that up into components? Yes, Fx and Fy. Basically what happens is, remember my box on my table. This is table, this is box. Is my box moving in the vertical direction? No, it's not moving in the vertical direction. So that means the net force in the vertical direction or in the y direction is equal to 0. Please tell me if I'm not making sense. Please tell me. Yes, Fn and Fg must be in your diagram. So F net in the y direction is 0 because my box is just chilling. It's just sitting on a table. Just imagine a box sitting on a table. I mean, I don't have to show you my eraser for you guys to imagine a box on a table. If my box is sitting on a table like this, and I'm applying a force that way, you aren't making sense. Okay, let me try. Okay, we've got a box sitting on a table, right? If I pull a box at an angle like this, so imagine it's you, like a little man over here, or a woman, and you're pulling this box, and you're walking that way. You're pulling the box upwards at an angle. Okay, we're pulling the box upwards at an angle. Which way will the box move? Which way will the box move? Isn't it getting lifted in the y-axis? No. So we're assuming that we are pulling the box, and we are walking that way and the box is moving that way. We assume that the box isn't lifting off of the table. That's a good question though. Thank you for asking that. Yes, the box is moving to the right. So guys, imagine it's like, now I don't have an actual box to show you guys, but I'm sure you can imagine what I'm saying. It's like, here, let's use this thing. There we go. That's my box. Cool. It's on my table. Okay, I know you guys are looking at it from a top-down view. Let's pretend I'm pulling this box. I'm pulling it at an angle, do you see? But it's moving to the right. It's not lifting up in the y-axis. That means that the net force in the y-axis is 0. It's not moving in the y-axis, it's moving in the x-axis. So, ma'am, is the direction of motion on the left. So which direction is the friction? Good question. Which direction is the friction? I haven't included friction in my diagram yet because I'm trying to focus on the applied force. Friction would be that way. Okay. So the box is moving to the right. Friction is going to the left. And the box is not moving in this direction. Is everyone with me? Please let me know if those of you that were confused are now with me. So the box is not moving in the y direction. Why is friction to the left? That's a great question. So friction is always, always, always in the opposite direction to the motion. Okay. How is F net y 0? Okay, the reason F net y is 0 is because the box is still in the y direction. It's like, imagine you're pulling a cart, like, you know, when you're a little kid, you can pull those carts along the ground with a rope and you're pulling it at an angle like that. You're pulling it at an angle, but you're not lifting it off the ground. Imagine it doesn't lift off the ground. It stays on the ground, but it's moving to the right. That means that there's a force, a net force in this direction, assuming that there's acceleration. But F net in the y direction is 0. Because the box is stationary in the y direction. Guys, do you know that Newton's second law is F net equals ma? Do you know what that means? F net equals ma. M is mass, A is acceleration. So if I'm talking about F net y, so F net in this direction, is the box accelerating up and down? So I'm pulling the box to the right, it's moving to the right, but is it accelerating up and down? No, it's not accelerating up and down. So acceleration is 0, and anything multiplied by 0 is 0. That's why F net in the y direction is 0. Okay, let's move on. So, which forces, look at my free body diagram, which forces are acting in the y direction? Can anyone see? Which forces are acting in the y direction? So we've already mentioned that Fn acts in the y direction, this one. Okay, what else acts in the y direction? Yes, the normal force. What else? What else acts in the y direction? I mean, the obvious ones are the Fn, Fg, and then, now this is where students get confused. Fn is in the y direction, Fg is in the y direction, and F applied y. What angle are we pulling it at? That's a good question. Let's say 30. Doesn't matter really. I'm just trying to explain something. We'll do a proper question. Fy. Now, as soon as I break F applied up into its components, f of x and Fy, it's almost like in my calculations, I ignore F applied. I'm only going to focus on Fx and Fy. I'm speaking about in the y direction. So which forces are affected in the y direction? Fn, Fg, and Fy. Those three added together, Fn, Fg, and Fy. Those three added together must give me 0. And now I saw someone say this earlier, and they are amazing. Who was that? You need to tell me. Someone said earlier that Fg, remember in this situation, we said that Fn, the magnitude of Fn, was equal to the magnitude of Fg, right? We said the magnitude of Fn is equal to the magnitude of Fg. That is not the situation we're talking about over here. Someone said it earlier. Who said it? You said that Fg was equal to what? So guys, what I want you to consider is Fg is the down force. The down forces will equal all of the up forces. Now the down force is F. So Fg will equal Fn and Fy. Fn and Fy. That's essentially what's going on here. And the way we get it from this equation is if I take up as positive, which of these three yellow ones will be positive? Which of these three yellow ones will be positive? If I take up as positive, so there we go, up is positive, that means Fn will be positive. It means that Fy will be positive. And what about Fg? Fg will be negative. Why? Because it's going down, and that equals 0. Now look what happens. If I take Fg over, so we leave Fn because it's positive, we leave Fy because it's positive, Fn stays there, Fy stays there. If I take Fg over, what happens? It becomes positive. And this is the equation that is true to this situation. Fn and Fy together give me Fg. Remember, in this situation over here, it was Fn is equal to Fg. And the reason why is because they were the only two forces in the y direction. So in this situation, Fn and Fg were the only two forces in the y direction. So technically, these two forces together, Fn plus Fg, would equal 0. That's why they would equal each other. And why is this one negative? Why would Fn be positive and Fg be negative? So if this statement is true, which it is, Fn plus Fg will give me 0 because the box isn't moving in this direction. How is this a true statement? What does that negative mean? Opposite direction. Well done. Well done. You guys have got this. You see, a big thing about science is sometimes people overthink it. You guys have got it. One has to be negative because it's in the opposite direction. Lovely. Okay. So I just, by the way, jumped into quite a complicated sort of like example and concept to understand. So if you got that, I'm very proud of you. You're doing well. Now, this is another thing that gets students. Are we doing force and vector diagrams? Yes, we will get to that when we get to questions. But yes, we are doing free body diagrams especially. Okay, now, in this question, I don't know if you guys can see. Okay, it says, if the object is on an inclined surface. Okay, so I skipped a page. Let's go back. Let's go back. This, let's zoom. Zooming in. Okay, in this example, if I had to draw my forces acting on this box, let's just pretend that there's an applied force acting up like that. This is F applied. And let's pretend that there's a friction force acting that way. Remember, friction is always in the opposite direction to the motion. So let's pretend we're pulling the object up the slope. How would the free body diagram for this look? Now, guys, the thing that you need to understand is that weight, always, the weight of an object, force of gravity, always goes from the object straight down to the ground. Right? What about the normal force? The normal force is always perpendicular to the surface. So here's the surface. I flip my ruler so it's perpendicular. This is my normal force. That is Fn. Can you guys now see that my object is on an incline? Now, is my normal force equal to my force of gravity? Let's label it Fg. Is my normal force equal to my force of gravity? Do we include components on a free body? No, we don't. So that's a very good question. I will get to that when we go through an example. So no, it doesn't. What we can do is, do you see that Fg is acting at an angle relative to the surface? So if this surface is inclined at 30 degrees, essentially what I know is that I can resolve. You see that word resolve? It means break weight up. I can resolve weight into its components. I have this one. Let's highlight it so they're different. What would I call this one, everyone? What is this component's name? If the blue one is Fg, what is that component's name? And then I've got this one, which I'm going to highlight in yellow. This one is in yellow. So what is the orange one's name? So this is FG. Remember, I'm breaking FG up into components. What that means is the orange one and the yellow one together give me the blue one. Yes, the orange one is FG perpendicular. And for the people that don't know why, it's because it's perpendicular to the surface. Here's the surface, here's my force. The orange one is perpendicular to the surface. The yellow one, so let's just highlight it so we keep our colors nice and the same. This one is FG parallel. FG parallel, yep. Why parallel? Because it's parallel to the slope. Yeah, I know some of you might find this easy. If you've done it already, this will be just more like revision. But I'm doing this live for, well, I really want to help people that are struggling as well. Okay. Here we just say F1 and F2. That's fine. It's just, it's nice to say FG parallel and perpendicular because it clarifies, it really, really tells you about the difference between them. So it tells you that this one's perpendicular to the slope, that one's parallel. Okay, so awesome. Let's carry on. Now, how would, if that angle's 30, that angle over there will be 30. And students often ask me why. Guys, it's just geometry. If that's 30, this hangs straight down. That is 90. If that is 90 and that's 30, then what do you guys think this angle over here is? That would be 60. If that's 60 and this one's 90 over here, that has to be 30. So now I did a whole lot of geometry for no reason. But basically, that angle is the same as that angle. Okay. FG parallel. So if it doesn't look parallel, it's because my drawing is quite bad. But anyway, so yeah, exactly. Do you see the geometry, guys? Lovely. FK. Okay, what is FK? So FK is force of, it's kinetic friction. You guys can also call it just friction in general, F. Okay, so that's how we resolve weights into components. Now, what is Fn equal to? The magnitude, so I'm going to write in here, the magnitude of Fn is equal to what? The magnitude of what? The magnitude of Fn is not equal to Fg anymore, like it was when it was on a flat surface. Remember, when we were on a flat surface, the magnitude of Fn was equal to the magnitude of Fg. It's not true for this situation. Yes, the magnitude of Fn is equal to the magnitude of Fg perpendicular. Well done, guys. And I mean, the easy way to think about it is because they're in the same plane. And these two forces, Fn and Fg perpendicular, the reason why they're equal is because they end up cancelling each other out or balancing each other out. And that's why this object doesn't go fly off the table, right? There's no net force in this direction, in the perpendicular direction. There's only a net force in the parallel direction. Okay. How would you calculate Fg perpendicular? So here's my angle, it's 30. So Fg perpendicular is adjacent to the angle. So Fg perpendicular would equal Fg cos 30. Fg cos 30. Fg parallel. Fg parallel. Look at the angle, there's 30. It's opposite the angle. So Fg parallel will be Fg sine 30. Okay, I hope that makes sense. And I do have a summary page on that if you guys want it. I did put it on a TikTok video yesterday. So there it is. There it is. So Fg perpendicular is Fg cos theta. Fg cos theta because it's adjacent. Fg parallel is Fg sine theta. Okay, there we go. Now, the last thing before we jump into some questions is the difference between static friction and kinetic friction. These are the formulae to calculate maximum static friction, and this is the formula to calculate kinetic friction, sorry. Okay. Could I take a screenshot? Of course you can take a screenshot. Okay, so this is the coefficient of static friction. Okay, it's this funny symbol here. That's the coefficients of kinetic friction. These are determined experimentally. They do not have a unit. That, sorry, I keep knocking the camera. That is the normal force. Now, we've spoken about the normal force. You should know what the normal force is. Right. What I need you guys to know is that static friction is always more than kinetic friction. Okay, can you make your notes on a PDF or something? Of course. When do we use those equations? So you can use these equations when they ask you to calculate static friction, maximum static friction, or kinetic friction. Okay, so when they say calculate friction, calculate static friction, calculate kinetic friction, you can use these answers. If you'd like, I can try and make these available as a PDF. They'll be linked in my TikTok bio, so if you don't follow me, remember to do that so you can access the links in my bio. Can you also do a horizontal shot? Oh, what do you mean? I will try and upload it as a PDF. Okay, let's move on. Now, Newton's first law of motion. What I need you guys to know is when we do Newton's laws, we're always going to start with F net equals ma. For Newton's first law, it involves situations where the object is not moving. So stationary, not moving, or it's moving at a constant or uniform velocity. So if you see in a question, they say it's stationary. The box, the object is not moving. It's stationary. It's moving at a constant or uniform velocity. It's moving with no acceleration. Then we know that it's Newton's first law. And that means I am left-handed, yes. Any lefties in the chat? On the live? Comment if you're a lefty. Left-handed. So acceleration is 0. And if acceleration is 0, why are we crying? Are we crying because I'm left-handed? I missed something. If acceleration is 0, F net is equal to 0. And that is the basis of Newton's first law of motion. Yay, more left people. Awesome. I have very few left-handed students, so it's really cool every time a student is a left-handed. Yay. Okay, F net equals ma. So F net equals 0. If we are dealing with Newton's first law, you need to start like this. F net equals ma, acceleration is 0, therefore F net is 0. Isn't that Newton's second law? Yes, so F net equals ma, we apply it to Newton's second law of motion, but I'm showing you that it essentially can be applied to Newton's first law of motion as well, but acceleration is 0, so it makes it 0. So essentially, this is how we start off Newton's first law questions. But I wanted to show you why. Why do we say F net equals 0? Okay. Newton's second law of motion, like we said, it's F net equals ma. So there is a net force. So in this, if they want you to do Newton's second law, they'll say that it's accelerating. It's not moving at a constant velocity. Okay, that's Newton's second law. And guys, should we jump into some examples? I think we should. What I did as well is I made this summary so I can show you guys. I made the summary, so I'll do one with you as an example. Newton's law of universal gravitation is harder. I know we're going to do that in the future. Okay, so I made the summary. If I have an object and I've got an applied force that way, that's what the free body diagram would look like. If I ask you to draw an equation and I'm speaking about F net equals ma, I'm speaking about F net in the x direction or in the horizontal direction. Now, everyone that's watching, I need you to focus now. I'm speaking about F net in the x or the horizontal direction. Which forces am I speaking about out of these 4 forces? Which forces am I speaking about? Okay, look, in the x direction. So I hope you know that's y, that's x. So in this situation, I'm speaking about friction and force applied. So F net in the x direction will equal force applied plus friction. Now you might be thinking, okay, cool lady, why are you telling me this? Knowing how to do these sorts of equations will help you when we get to questions. If I'm speaking about F net in the y direction, which two forces am I talking about? So this would be F net in the x direction. If I'm talking about F net in the y direction, I'm speaking about Fn and Fg. F net in the y direction, y is a plus, I'll explain now. F net in the y direction is Fn plus Fg. So guys, when we mark your papers at the end of matric, and we'll mark the same in grade 11, what we do with markers is you always start the Newton's questions off with F net equals ma. If it's a first law question, Newton's first law, we'll know that eventually F net will equal 0 because acceleration is 0. You always start off by adding plus signs in between. It's called vector addition. I'm going to get to the negatives now, just listen. So you always, and they actually look for this. I went to a workshop on how to mark Newton's laws questions as a South African physical sciences educator. And they said, when I say they, I mean people who set the final exams, said that students need to first write forces as vector additions, which means there has to be plus signs in between. The negatives come in when I substitute. So let's say I tell you, for example, and I'm going to use my pencil because I want to erase it. Let's say I say, for example, F applied is 50 newtons and the force of friction is 20 newtons. Now the negatives come in because I choose the right. I'm going to choose the right as my positive direction. If I choose the right as my positive direction, which of these is going to the right? Which of the forces in the x direction is going to the right? This one. This force is going to the right. So this one is going to be positive. So it would be positive 50 plus, now friction is going to the left, which is my negative direction. So it would be plus negative 20. I hope you guys can see the difference. So when we start, we always start off with plus signs. Then when we substitute in, we put the negative because friction is going in the negative direction. So our net force in the x direction is 30 newtons to the right. You need to give a direction, please. The same thing with F net in the y direction. If I choose up as positive, when I substitute in a value for Fn, it'll be a positive value. When I substitute in a value for Fg, it'll be a negative value. Okay, or east, yes, right or east, 100%. So, knowing how to do this, can you write right-handed? I can actually, I'm not the best, but I'm not bad. Okay, so I can upload this for you guys somewhere. Why is it to the right? Please explain. Okay, what do you need to know? Okay, why is it to the right? Okay, so it depends on what I choose. So I chose the right as my positive direction. So when I say 50 plus negative 20, so 50 minus 20, I get a positive answer. Do you see there? I get a positive 30. Because I get a positive answer, it means it's in my positive direction. And I chose to the right as my positive direction. That's why it's to the right. Okay. Let us go. Your left-handedness is throwing me off. I'm so sorry about that. Sorry I was born this way. Okay. Let's do this example, everyone. So this example is a relatively basic example. I hope you agree with me when we go through this. I did this with my class yesterday and they found it pretty easy, I think. So let's see what you guys think. So I hope you guys can see it. Might be a bit blurry. I've got a 50 kilogram object is being pulled across a surface with a force of 50 newtons. So that is my applied force. 50 newtons is my applied force. A friction force of 30 newtons acts on the object as it is being pulled. So do you see there I wrote Fk? Fk is force of, it's kinetic friction, and kinetic refers to movement. And clearly this object is moving. Okay. Is that really grade 11 and grade 12? Well, this is a basic example for grade 11 and grade 12. Very basic. Okay, so the first thing, and I tell this to my students all the time, the first thing you've got to do you see they don't ask for it, but I want you to draw a free body diagram first. Grade 11s and matrics, this will help you. I know this is an easy example, so maybe not so much in this one, but it definitely will help you. Okay, so force applied is to the right, force of friction is to the left. It's always in the opposite direction of the motion. then the normal force is up and Fg is going down. Okay. Now, quick question for you guys because you've been listening and you're doing so well. In this situation, is the normal force equal to the force of gravity in magnitude? Is the normal force equal to the force of gravity in magnitude? Okay, calculate the normal force. Now, how I do this is I know that the normal force, yes, it is equal to the force of gravity. Yes. Well done, everyone. In this example, I know that the normal force is equal to the force of gravity in magnitude. So this question is 3 marks. Now, when I show my class, I tell them you need to do it properly. What I mean by that is normal force is in the y direction. So F net in the y direction is equal to Fn plus Fg. This is what I mean by do it properly. Just watch. I know you guys got to the answer already. I'm going to choose up as positive. That means, oh, by the way, what will F net in the y direction equal? What will F net in the y direction equal? This box. Is it moving in the y direction? No. So F net in the y direction will be 0. Fn is what I'm looking for. Fg is mass times gravity. Fg is mass times gravity. Well done, it is 0. Mass is 50. Gravitational acceleration is 9.8. That means that Fg is 490 newtons down. But I chose up as positive. So let's go and put in our negative 490. Why negative? Because it's going down. That means that Fn, if I take negative 490 over, it becomes positive 490. It's 490 newtons upwards. Guys, you need to give a direction. Can I tell you something? For all of those, is it 0 because it's not accelerating in the y-axis? 100%, well done. It is 0, so F net in the y direction is 0 because it's not accelerating this way. Well done. Okay. If you did not give a direction in your answer, it's wrong. So when I come with my red pen and you don't give a direction, I'm going to mark your answer wrong in matric if I mark your paper. And it is. That's how we mark. That's how matric markers mark. Why do you need to give a direction? They said calculate the normal force. They didn't say the magnitude of the normal force. Okay. There we go. That is the normal force done. Calculate the normal force. How would I calculate the coefficient of kinetic friction? So, the coefficient of kinetic friction. Now, I hope in your mind you're remembering the formula I showed you. You need to remember the formula. It was this one. It's on your formula sheet. Fk equals the coefficient of kinetic friction times the normal force. You need to remember that. Now, what is the frictional force? They gave it to us. It is 30. They gave it to us in the question. How nice of them. Okay, 30. The coefficient of kinetic friction is what I'm looking for. And what's the normal force? The normal force is 490 newtons. So in the place of normal force, I'm going to put 490 newtons. How do I get the coefficient of kinetic friction? I divide by 490 on both sides. So 30 divided by 490 equals 0,06. I'm going to round off to 2 decimal places. 0,06. And I don't know if I haven't mentioned this to you guys yet, but this is unitless. In other words, it doesn't have a unit, which is great. It's unitless. It's not even comma. Right, now I'm confused. Okay, I'm sorry if I'm confusing you, but the frictional force is given in the question. So it says a friction force of 30 newtons. And then the normal force is 490 newtons because we just calculated it there in our previous question. Okay, so we're just substituting into this formula. This formula is the formula to calculate kinetic friction, or we can use it to calculate the coefficients. And there we go. Got it. Awesome. Why are you confused? I'm sorry. Please let me know why you're confused. Okay, number 3 says calculate the resultant force. Now, grade 11s and grade 12s, we agreed, is there a resultant force? Is there a net force or a resultant force? in the y direction for this object? Is there a resultant force in the y direction? Is there a resultant force in the y direction? Tell me, tell me, tell me. No. There's no resultant force. F net in the y direction is 0. So that's not what the question's asking. The question is asking for the resultant force. Obviously, they mean in this direction. So F net in the x direction is equal to, now, this is why I showed you that table. Which forces are acting in the x direction? It does have a resultant in the x, exactly. Which forces are acting in the x direction? Remember, the x direction is this direction. It's F applied and Fk. So we've got F applied plus Fk. And now everyone asks me, but ma'am, why did you say plus? Because friction is going in the opposite direction. You are correct, but we always need to write out plus signs first. When I substitute numbers in, that's when I put a negative. So let's do it. My force applied, I gave to you in the question, it's 50. So that's a positive 50. Oh, by the way, I'm choosing to the right as positive. You can choose the other way as positive, it's fine. So I'm choosing to the right as positive. F applied is going to the right. So that means the force applied of 50 newtons is going to be positive. Then I go plus. My friction force is going to the left, which means that this 30 newtons is going to be negative. So it's 50 minus 30, and we get 20 newtons. Now, what's my direction here, everybody? What's my direction here? My direction here, well, I got a positive answer, and I chose to the right as positive. So that means my direction is to the right. I see some people are asking me what happens if I choose to the left as positive. It's a very good question. Let me do it quickly. So if I choose to the left as positive, if I chose to the left as positive, okay, so not to the right, if I chose to the left as positive, F applied is now going to the right. So F applied would be negative 50 because I chose the left as positive and F applied is going that way, plus force of friction is going to the left, which would be positive. So it would be negative 50 plus 30, and you would get negative 20. But look at what I've got. I've got negative 20. I chose to the right as positive. So to the right is positive, right? I got negative. No, sorry, I chose to the left as positive. Sorry, I'm confusing myself. So I chose to the right, to the left is positive for this question. That's why my free body diagram, sorry, I'm looking at the wrong thing. My free body diagram, if applied is that way. So if applied is to the right, that's why it's negative 50. Then my force of friction is to the left. That's why it's positive 50 because I chose to the right as positive. But I'm getting a negative answer, right? Which means that I change it to 20 newtons to the right. It's the same thing. You get to the same outcome. 10 years out of school and I never used this stuff. Did you do it in school? Well, if you want to study science or engineering, you'll use it. Okay, calculate the acceleration of the object, question number 4. So now I've got the net force. The net force is 20 newtons to the right or in the positive direction. So I always tell my students in the positive direction is a good direction to give because, I mean, then you're not really saying left or right. In the positive direction, 20 newtons. Okay, now they want the acceleration. So what we do for number 4 is F net is equal to mass times acceleration. My net force is 20. My mass is 50. My acceleration is what I'm looking for. I divide by 50 on both sides, so I get acceleration is 0.4 meters per second meters per second in the positive direction or to the right or whatever you chose as your positive direction. Okay, there we go. Are we going to use it in a job? if you do engineering, you definitely do use forces and the balance of forces and stuff like that. If there's any engineers here, they can tell you that. Okay, how was that, everybody? Would you like to try another example? How did you find that? Did you find that okay? Would you like to try a more difficult example? What do you think? I can do another one similar, or I can try and get a more difficult one. Okay, this comes from a final November paper. So I wrote here, DBE November 2018. Okay, these are grade 12 examples, by the way. This comes from a final grade 12 paper. I think it's final grade 12 paper. Remember, we teach it in grade 11, but it is grade 12 work, so similar level. So let's do this one quickly. So we've got, okay, define the term kinetic frictional force and state Newton's first law of motion in words. Those are theory questions and I'm not going to go over at this moment. I did say I'll upload the definitions for you guys if you would like. So please follow me if you want. This is grade 11 level. Guys, I had to explain to my class today that we teach it in grade 11. So there isn't really a thing like grade 11 and grade 12 level. You get easier and more difficult examples. But just please remember that we teach it in grade 11. We examine it in grade 12. So there's no such thing as grade 11 and grade 12 level. It's just easier versus more difficult examples. This is grade 12. This is grade 12 questions. Okay. Calculate the magnitude of the horizontal components of the applied force. So I'm going to go a bit quicker. So in this question, the applied force is acting at an angle. So essentially what I have is I have the box. I have 90 newtons. That's the applied force. It's acting at an angle relative to the surface, which is 50. If I must calculate the horizontal component of the applied force, that is this component over here. That is that component over here. So that is F applied horizontal. Let's call it F applied parallel. F applied parallel. Here's my angle, it's 50. So which trig ratio will I use to get that? So this is question 3.3. I skipped 3.1 and 3.2 because it's definitions. So I will use, what do you think? Which trig ratio will I use to get that answer, do you think? I will use cos. And the reason I use cos, okay, so why parallel? They want the horizontal component. So you can call it F applied horizontal or F applied X or whatever. Just, it doesn't matter. So I just call it F applied parallel because it's parallel to the surface. Okay. So I use cos because the angle's over here. I'm looking for the adjacent side. So it's 90. So let's go F applied horizontal in the X is 90 cos 50. 90 cos 50 and you get 57,85 newtons. They wanted the magnitude. So I don't need to give a direction. They wanted magnitude. There it is. Okay, 3.4. Calculate the magnitude of the normal force. 3.4. Now, remember everyone, I said draw a free body diagram, even if they don't ask for one. So I've got FG going straight down, that's FG. I've got the normal force going straight up, that's Fn. I'm going to have a friction force, Fk, and this is force applied. Force applied. Now guys, just look at what the question says. It says the box moves at a constant velocity. It says the box moves at a constant velocity. What would happen if we gave direction as well? Even if they don't ask, would it be marked down? No, not necessarily. I always tell my students, if you give more, they can't mark you down. You're giving extra information. But I mean, yeah, so you don't have to because it says magnitude. But if you do, I don't think they can penalize you. Okay. It says the box moves at a constant velocity. Does that mean this is a Newton's first law question or Newton's second law question? The box moves at a constant velocity. You guys tell me quickly. It means Newton's first law. Yes, because a constant velocity means that acceleration is equal to 0, which means F net is equal to 0. Right. Now, because they want the normal force. Now, this is 4 marks, everybody. 4 marks for the normal force. Okay? They want the normal force. Look at the normal force. The normal force is acting in the y direction. Which other forces are acting in the y direction? Please, can we do one with 2 objects? There's one coming. Which other forces are acting in the y direction? I've got Fg acting down and And, now this is important, my students forget sometimes about this. This one can be broken up into its components. This is F applied parallel. This is F applied perpendicular. F applied perpendicular is also acting in the normal forces plane. So a lot of people will say FG and Fn, but you'll forget about F applied perpendicular. So if I'm looking for the normal force, I'm going to work with F net in the y direction. That will equal 0. F net in the y direction will equal 0 because the object is not accelerating in the y direction. F net in the y direction is Fn plus Fg plus F applied perpendicular. Those all together should give me 0. Okay, now I'm going to choose up as positive. Remember, the question wants me to calculate the normal force. So I'm looking for Fn. I can sub in a value for Fg. How do I calculate Fg? Fg is equal to mass times gravity. Mass is 45. Gravitational acceleration is 9.8. So 45 times 9.8, I get 441 newtons. So I can sub that in for Fg. But, a big but, Fg is going down, and I chose up as positive. So I need to sub in negative 441. That's for Fg. So let me just color code in case you guys are missing what I'm saying. Fg is negative 441 because it's going in the negative direction. Okay, yeah, some schools will say 10, but we use 9.8. It's more accurate. It's not as accurate as it could be, actually. Then, F applied perpendicular. This angle is 50 degrees. 50 degrees. I'm looking for F applied perpendicular. So, over here, remember, I worked out F applied parallel or F applied in the x direction, and I use cos. To find F applied perpendicular, I'm going to use sine. So, it's 90 sine 50. And all of that must equal 0. Sorry, I ran out of space there. Okay. 90 sine 50. Well done, guys. Well done. Awesome. Then, now what? I'm looking for Fn. So I need to isolate Fn. So what I do is I go Fn and I take all this stuff to the other side. And I basically end up getting that Fn is equal to 372,06 newtons. There we go. That's my answer. There we go. Are you a physics teacher? Yes, I am a physics teacher. Physics and maths. I am a physical sciences and maths teacher. Nice to meet you. Okay, there is my answer. And they wanted magnitude. So that's it. Okay, why is it 90 sine 50? Thank you for asking the question. It is 90 sine 50 because the force applied, so we're looking for force applied perpendicular, which is this one over here. Hope you can see it. That one over there. This over here is 90 newtons. This is my angle. My force applied perpendicular is opposite. And we know that the trig ratio for opposite over hypotenuse, remember this 90 is my hypotenuse, opposite is sine. So it's 90 sine 50. Okay. I mean, the real reason is because it's sine theta equals opposite over hypotenuse. Okay. In this case, my angle's 50. My opposite is F applied perpendicular, and my hypotenuse is 90. So you take the 90 over, and it becomes times. So it's 90 times sine 50. Okay, awesome. My last question here is calculate the coefficient of kinetic friction. So 3.5. Calculate the coefficient of kinetic friction. That is that value over there. Now, our teacher gave us this today to work out. Yay, that is so cool. Okay, coefficients of kinetic friction. Now remember guys, I showed you a formula that you can use to get the coefficients of kinetic friction. It was this one. Fk equals the coefficients of kinetic friction times n. But the problem is, the problem. I thought the same question too. Sorry, I missed the question. Okay. I'm sorry, I missed the question. Okay. Just re-ask your questions if I missed it. Sorry. Okay, Fk equals mu Kn. That's symbol for coefficient of kinetic friction. But, so I'm looking for this. The question wants this. Do I have the correct information in order to work this out? So basically, do I have the normal force? Yes, I do. There's the normal force. I just worked that out. That's amazing, right? But do I have Fk? No, I don't have Fk. So I'm trying to work out this one. I have the normal force. I just got it from the previous question, but I don't have Fk. So I first have to find Fk. So where's Fk on my diagram? So if you look at the diagram, what if they didn't give you a force but ask you to calculate it? So that's kind of like what's happening here. They want us to calculate that, but we don't have that. So we first need to find the missing force. So if we look at my free body diagram, where is Fk? Remember, I'm trying to find Fk first. Fk, let me use a different color. Fk is over here. There's Fk. So Fk is acting in the horizontal or the x direction. So Fk is going that way. What other force is acting in the x direction? I've got F applied parallel. Those two forces together. If I add them together, guys, if I add them together, what should they give me? They should give me 0. How did I know that? Why would the two forces in the x direction give me 0? The two forces in the x direction will give me 0 because the object is moving at a constant velocity, which means that there's no acceleration. So basically what I can write here is F net in the x direction will equal 0 because the object is moving at a constant velocity, constant v, constant velocity. Okay, now F net in the x direction, which two forces are acting in the x direction? Fk plus F applied parallel. That must give me 0. I'm going to choose to the right as positive. If I choose to the right as positive, which of these will be positive? That one will be positive. Now, what is the value of that one? What is the value of F applied parallel? Well, we worked it out in 3.3. F applied parallel, do you see 3.3? Calculate the magnitude of the horizontal components of the applied force. Okay, so this one is that answer over there. So that is Fk is what I'm looking for, plus that 90 cos 50. You could have subbed in that answer as well, and that must equal 0. So that means Fk is negative 90 cos 50, which is 90 cos 50 newtons in the opposite direction, or let's say to the left. Now, why do I care about Fk? That's Fk. I care about Fk. Why is it equal to 0? Good question. So it's equal to 0 because the net force in the x direction, so here's my x direction. My net force in my x direction is 0 because the object is moving at a constant velocity. Okay. There we go. Awesome. That is why it's equal to 0. Now, that I can substitute in there. So then I've got my force of friction, I've got my normal force, and I can then get my coefficients of kinetic friction. Yes, no acceleration in the x direction. So let's rewrite my formula and work out the answer. So my force of friction, force of kinetic friction, is 90 cos 50. My coefficient of kinetic friction is what I'm looking for. And then my normal force is that value over 372,06. Therefore, my force of kinetic friction is that value divided by that value. And what did anyone get the answer? Did anyone get the answer? I got 0,155488 blah blah blah. If I round it off, it is 0,16. Okay. isn't the normal force just the weight? That's a very good question. No, in this situation, the normal force is not the weight. And that's because the normal force is equal to the weight if there is no other force acting upwards. But in this example, yes, you also got 0.16. Well done. The normal force is acting upwards. The force of gravity is acting down, but there's another force acting upwards. And that's why the normal force and this up force, so these two up forces together, is equal to the force of the gravity. Do you teach grade 10 biology? I don't teach grade 10 biology this year, but I did study biology in university all the way up to honors level, so I'm 100% qualified to teach it. Is Fn and Fg the same value? No, not in this example. So you may have joined the live late, but I did go over that if there's no other force, then Fg is equal to Fn. Then those two are equal. But as soon as there's another force acting upwards and at an angle, then Fn is no longer equal to Fg. Fn and this force together, so these two up forces, is equal to my down force. Can you do algebra? 100%. I'm definitely doing algebra in the future. When do I go live again? Okay, so hold on. Let me swap the camera over. Give me a moment. Right. Okay. How was that, everybody? I hope that went okay for you. I'm a technical science teacher. You're doing great. Thank you so much. That really means a lot to me. Can you do Euclidean geometry? I'm going to be doing geometry, algebra, and all that stuff in the future. So guys, we've come to the end of the live. It went great. I'm so glad that I helped you guys. I really am. We've come to the end of the live. I do have more questions prepared. Now listen to this. What I've thought of doing is I've been thinking of going live for this particular topic that we covered, but on a different platform, not TikTok. Someone asked me on my one of my TikTok videos if I can go live on Zoom. Now I've been planning to do workshops on maybe not Zoom. I'm thinking maybe Google Meet. I'm not sure. Wait, real quick. Why is it not negative 0.96? Okay, so you never sub a negative into my friction formula. So basically, over here, friction is negative, but we never sub a negative into this formula. So then it's a positive divided by a positive will give me a positive. Okay. Sorry. So I will be doing live lessons on another platform. So if you're interested in that, please make sure you follow me. Then in the link in my bio, you'll see a tab that says grade 10, 11, and 12 physical sciences workshops. I want you to click on that website. I made a website and I do have a YouTube channel. I'll get to that in a second. You can click on that link and it'll take you to the website that I made and you can sign up. I'll be doing free workshops for at least the first 2 terms of this year. It won't be a lot because I also want to do TikTok lives and stuff like that, but I'm planning on doing at least 1 a term, and it will be on big topics that people struggle with. So I think this is a topic that people struggle with. So maybe a bit closer to the exams, I will do more on Newton's laws. And then I already have these examples prepared. So 2 objects on a slope attached by a string and things like that. So I do have them prepared and I'm ready to go for that. If you guys are keen, you can follow me and click on the link in my bio for physical sciences grade 10 to 12 workshops. And I do have a YouTube channel. It's called Maths and Science with Miss M. It's also linked in my TikTok bio. I will be doing vertical projectile motion as well for matrics at a later stage. And of course, chemistry and all those things when we get there. It's just I tend to do my lives according to what I'm also teaching at school. Okay, any last minute questions? I hope that helped you guys. Remember to follow me if you don't already because now you are my student. Okay. If the frictional kinetic force is negative direction, you don't use a negative. Not for that formula. Can you do chemistry? Yes, I do chemistry as well. The next session will probably be sometime next week. I'll let you guys know what grade it'll be. Oh, thank you. Okay. Awesome. It's a pleasure, everybody. I'll see you guys in the next live and also in my videos. If you have any questions, by the way, you're always welcome to comment on my TikTok videos. I do try and respond to as many comments on my videos as I can. You'll see, I always try and comment back. So thank you so much for the support. Remember to always share your videos with my friends, because I don't know if a lot of people know that there is a physical sciences teacher, maths teacher on this app. So I know you guys know about the amazing life sciences teacher on this app, but I'm a physical science teacher also here trying to help you guys. So I hope that I can do that for you. So yeah, awesome. I'll see you guys in the next live, and I hope this one helped you. Have a great Thursday afternoon and weekend coming up, everybody. Bye, guys.